I'd like to welcome you to the first of the 2021 series of Chiba's visiting lectures. I am Parminder Sachdev. I'm the co-director of the Center for Healthy Brain Aging at the University of New South Wales in Sydney. Before I begin, I'd like to acknowledge the Veridical people who are the traditional custodians of the land on which this center stands and pay my respect to their elders past, present, and emerging. As you know, the international lecture series of Chiba has now become very popular. It's become a regular feature, and this year we are going to have 6 lectures, all of whom are internationally distinguished lecturers. And it's my great pleasure to welcome the first lecturer, and that's Professor Roddy Roediger, who is from the Washington University in St. Louis. He's the James S. McDonald Distinguished Professor of Psychology. His research focuses on learning and memory. And in fact, he came to prominence for his work on false memories. But he has published extensively on various aspects of cognitive processes involved in remembering. In fact, I'd like to also mention that our noteworthy connection with Professor Roediger also is that one of his former students, Katia Numbers, is an early career researcher at Chiba. She's the coordinator of the Sydney Memory and Aging Study and a rising star. So the way the proceedings run is that we will have the lecture first and then a time for Q&A. And of course, as the lecture proceeds, you are most welcome to click on the Q&A button at the bottom of the screen and type in your questions, which will be collated through the lecture, and we'll respond to as many questions as we can through this period. Of course, the attendees will not be visible to the lecturer or to the panelists, but all your comments will be seen. You can actually have these comments seen by all attendees. Now, thank you again. Thank you very much. And of course, welcome Professor Roediger for your talk, Super Aging and Super-Duper Aging.
Good morning. Today I'm going to be talking to you from North America about super aging and what I call super-duper aging. And I'll tell you what these things mean. So thank you for inviting me to speak to the Center for Healthy Brain Aging. I appreciate the invitation. And this talk will be a little bit of a jokey talk, as you'll see, but I hope to make a serious point. Now, before I get started, let me also mention that my speech, as you'll notice, or maybe have already noticed, is a little bit off due to the fact that I had surgery on my tongue and mouth 14 years ago, and it's made my speaking difficult. I also have difficulty saying R's. So you can tell from, especially in the initial position, so you can tell from my name, that's not an advantage. When I go to Starbucks now, I refer to myself as Henry. The origin of this talk was an experience I had in 2016. In fact, on July 18th, I went to a session at the International Congress of Memory in Budapest on exceptional memory abilities. And it was a great session. And at this session, there was a talk by Jim McCall on his work on exceptional autobiographical memory. There were some other talks. And then the last talk of the session was by Emily Rogalski and her colleagues at Northwestern University on what she called the super aging study, neurobiologic factors coupled with unusually high episodic memory of people over the age of 80. So I listened to her talk with great interest. I'd heard the word super aging, but I didn't really know what it meant, except the obvious, people who are really old and do really well. And as I was listening to the talk, the thought occurred to me, both during and ever since her talk, Mark McDaniel and I, my colleague Mark McDaniel and I really blew it. And I will be explaining that today, how we blew it. And so today's presentation will also be a lesson in how to frame your research and how not to do it. Mark and I chose the how not to do it way, as you'll see. Now, what is super aging? Super agers, as defined by Rogalski and her colleagues, are people who are over the age of 80, who score like people who are 50 to 65 on the delayed verbal recall score on the Auditory Verbal Learning Test, or RAVLT, which I assume many of you are familiar with. I won't go into it now. And the people they call super agers are those who scored within one standard deviation of a sample of 14 subjects who were themselves aged 50 to 65, mean age of 61. And in their sample at Northwestern, they found 12 super agers with a mean age of 83. And they did some structural scanning on these people. They showed they had higher cortical thickness, and they showed that certain regions of the brain seemed to be enlarged. So that was it. In this first study, the first paper that came out was a brief communication in the Journal of International Neuropsychological Society in 2012, with Rogalski as the senior author and Teresa Harrison as the first author. And they showed, as I said, certain areas of the brain, like the anterior cingulate cortex, were enlarged in the super agers. So super aging is defined as people who are over 80 who score on average like 61-year-olds. Now, I'm 73 myself. I remember 61, and really 61, you're in no great shape. Sorry to say that, but 61 is still old. So showing that 83-year-olds are like 61-year-olds, I guess that's super aging in their definition, but it didn't strike me as overwhelmingly good performance, because 61-year-olds, as we know, have already declined. But whatever, this paper became very famous. All kinds of, if you Google super aging, you come up with something like 280,000 hits. Here's a paper that was in the New York Times Sunday Review by Lisa Feldman Barrett, and there's all kinds of popular press on super aging, and lots of attention given to it at my university's Aging Center and many other places. Jeff, probably at yours too, but since you're interested in healthy brain aging. So back to Mark and me. What do we have to do with this? Well, from 2001 to 2007, we had 2 National Institute of Aging grants to study aging and memory illusions, in other words, false memories in older adults. And we also looked at individual differences in these older adults. And we have a number of what I'm now thinking of as underappreciated publications from this project. And so the data I'll be showing you, they are fairly old. Not that you've heard of them, of course, but they're still fairly old for us, but as I say, underappreciated. So our grant was looking at age differences in illusory memories in 4 different paradigms. I'm only going to talk about 3 of them with you today. And we looked, as I say, at individual differences in older adults, but we didn't use the Ray delayed test as Rogalski et al. Did, but we used a set of neuropsychological tests that I'll talk about in a moment that are ones that are purported to measure frontal functioning. And I say purported because although they're standard neuropsychological tests to measure frontal functioning, whenever I gave the talk on this, neuropsychologists and others would tell me, oh no, that I have a patient who barely has frontal lobes and he can do well on your test. So I'm not a neuropsychologist, so I couldn't really argue with them. But nonetheless, we're using classic neuropsychological tests. And we separated older adults into those who scored well and those who scored less well on those tests, and we compared them to each other and to younger adults. So that's what I'll be telling you about today. Now, most memory research, as you know, is conducted with college student samples. And psychologists like me get a lot of grief for that. We are told, oh, it's terrible, you're using just these select samples. But in a way, I kind of wonder about that, because when I look to my colleagues in biology, they often look for model systems and they study model systems. So if you're interested in studying genetics, you start with Drosophila, the hardy fruit flies. If you're interested in lots of other things, you study mice, say cancer. Often people start with mice models and then they work their way up to eventually human models if all works out well. And so if you stop to think about it, college students are a model system for studying learning and memory, because years of schooling have shown them to be excellent, have excellent memories, and to be excellent learners and memorizers. The ones who weren't good dropped by the wayside during those years of schooling. So the ones who make it to university are the ones who have excellent memories. And that's great if you're interested in looking at a model system for factors that improve memory or make it good, I think. However, one problem is if you're interested in studying errors of memory or false memories, then young adults might be problematic. And the problem is that college students may not make many errors relative to children, to older adults. College students might be at the pinnacle of their memory powers. And so perhaps older adults, Mark McDaniel and I argued in our grant proposal, might be a model system for studying memory illusions or false memories due to poor memory functioning in this group. So let's consider the first paradigm that I'll talk about. It's something named after me and Kathleen McDermott and James Deese, who originally started it back in the 1950s. Kathleen and I developed the paradigm from some early work by Jim Deese, then at Johns Hopkins University. And basically, the paradigm is the essence of simplicity. We present a list of words to people, college students, in fact, originally, and we show that the paradigm is very good at getting them to falsely recall and falsely recognize words that are not in the list we present to them. And so it's a false memory in the sense that they're remembering something that was never presented to them, as in most false memory experiments. And as I say, the original experiments were with college students. And I'll just show you a couple of results. So if you present, here's a list of words: bed, rest, awake, tired, dream, so forth and so on, down to drowsy. If you present that list of words, and we had in this original paper 24 lists like this, what you see in the graph that is portrayed there is probability to recall as a function of serial position. And you see the classic serial position curve in memory. The last few items are well remembered, the last item's almost perfectly remembered, and the first few items are well remembered. The ones in the middle are lower. Now, the dashed line in this graph is probability of recall of a word that was not presented in the list. And that word, in the case of this list, was the word sleep. So if you present these 15 words, people 57% of the time will recall the word sleep, which is not in the list. As you can tell from looking at the list, those words are associated to sleep, but sleep isn't there. So sleep is, we think, subconsciously or maybe even consciously activated, and it's remembered just like it was a word in the middle of the list. Now, in replications of this study, some people find probability recall of the critical item, as we call it, the word sleep in this case, to be slightly above those in the middle of the list. Other people find that the critical item is recalled just like it's in the middle of the list. Anyway, it's a very powerful phenomenon in recall. And that's interesting because free recall in particular, is thought to have a high selector mechanism, as the psychologists called it in the 1960s, and meaning that people rarely make errors in free recall. But here's a case where this is free recall. People just are told recall the list and any order you want to. And nonetheless, people include this word sleep. Now, following this, we also gave recognition tests for these words. And we had words that were studied in the list, like bed, rest, and awake. So you can see on the left the probability of probability of recognition of calling the word old, if it was actually in the list, was about 80% in a recognition test. Just seeing a whole lot of words. A recognition test is just seeing a whole lot of words individually and saying yes or no as to whether the words are in the list. And people say yes about 80% of the time for studied words. If it's a non-studied word that was unrelated to the list and a lot of other lists, probability of false recognition was very low. But on the far right, you see if the related word was presented on the recognition test, people falsely recognized it at the same rate as if the word had actually appeared in the list. This happened whether or not they recalled it previously on the previous recall test, although, of course, if they previously recalled it, they tended to falsely recognize it more than if they hadn't. But the phenomenon occurs whether they recalled the word or not. And further, for these related words, if you ask people to give confidence ratings to all the words, people rate the related words they're just as confident that they actually recognize the related words like sleep that weren't actually in the list as for the studied words. And further, if they're asked, do you remember the moment when you heard that word in the list? They again say they remember the moment they heard it for the related words, just like they do for the studied words. So phenomenologically, these are very powerful and real false memories. High confidence, I remember the moment it occurred. So this is with young adults, how powerful it is. Now, this confirms a quote from Mark Twain, another psychologist who was from Missouri about 100 years before me, who said in one of his later essays in his life, when I was younger, I could remember anything, whether it had happened or not. But my faculties are decaying now, and soon I shall be so I cannot remember any but the things that never happened. It's sad to go to pieces like this, but we all have to do it. So if we want to turn this quote into a hypothesis that makes a prediction, we can say, well, according to Mark Twain, older adults should show greater forgetting than younger adults. He says, I can remember anything, whether it happened or not, but my faculties are decaying. And so that means they can't remember the things that did happen. But they should also show a greater propensity to errors and illusions of memory than younger adults. So a chapter Mark and I have is called Testing Mark Twain's Conjecture. That was the subtitle of it, which is basically what our research was about. I want to talk about is one done by my colleague Dave Bellotta, and which I'm part of the et al. And what we did in this study was present 3 different groups of subjects with DRM word lists and examine false recognition. And we looked at young adults who were Washington University college students. We looked at older adults with no apparent neuropathology whatsoever, as far as we could detect from a number of tests, battery of tests. And then from that same battery of tests, we also selected older adults with mild Alzheimer's disease. And these last 2 groups were matched on age and education. So, and other factors too, but critically age and education. And so we were interested in seeing what would happen with older adults and older adults with Alzheimer's disease show greater false recognition in the DRM paradigm that I just told you about. Here are the results from the Bellotta study, along with all the co-authors at the bottom. And on the left is the probability of saying old or making a hit to studied words. So this is correct recognition on the left. And what we see is that young and older adults don't differ. Sorry, I don't have error bars here. I borrowed this whole slide to make this point that I want to make. And older adults and younger adults often don't differ on recognition tests because recognition tests provide what Gus Crate calls high levels of retrieval support. However, the older adults who had mild Alzheimer's disease, that's diseases of the Alzheimer's type is what DAG stands for, they were inhibited. They did not recognize as well. On the right-hand side, we see false recognition. And what we see now is that older adults and older adults with diseases of the Alzheimer's type show higher false recognition than younger adults. So even though older adults without pathology didn't differ in correct recall, they did differ in correct recognition, they did differ in erroneous recognition. Now, it's surprising to us that people with Alzheimer's did not show even enhanced false recognition. But if you look on the left, what you see is that people with disease of the Alzheimer's type maybe just didn't respond as much. And so what we did in the next analysis is we matched a subset of the sample of older adults and those with Alzheimer's disease in accurate recognition, and to see what would happen if we match accurate recognition, what would happen to false recognition. And so at the top here, you see, oh, I'm sorry, this is recall, not recognition. My apologies all along. So we see here, this is vertical recall at the top, false recall at the bottom, and we see that the very mild Alzheimer's patients showed higher false recall than did healthy older adults. I'm sorry, this was the recall part of the study. The other part was the recognition part. But anyway, when you match them on correct recall, the patients with diseases of Alzheimer's type show higher false recall. Now, why is this? And I'd say one of the primary theories of what happens in aging in older adults is that, and proposed by a number of people, including Dave Bellotta, Jan Ducek at my university, Morris Moskovich, Gus Craik, and Don Stuffs at Rotman Research Institute, Pat Rabbit, Marcia Johnson too. Basically, the idea is that the effects of aging on memory are due to declining functioning of frontal areas. We know frontal areas decline disproportionately as the brain ages, and the belief is that this leads to problems in attentional control and monitoring. So particularly problems in force monitoring, where did I learn this, and in inhibition of errors. And therefore, increases in illusory recollection in older adults should be most prevalent in older adults with the poorest frontal functioning. That was one of the guiding motifs of Mark McDaniel's and my grant proposal. And the corollary to that is maybe if we can find older adults who are very high in frontal functioning, they might not differ much from younger adults. Now, let me go to our test of frontal lobe functioning. We based our work on work by Glusky and her colleagues, Betty Glusky at Arizona State University and her colleagues, from a 1995 paper. And what they did was to do a factor analysis on a whole set of tests that were thought to assess frontal lobe functioning. And what they did was to come up with 5 tests that seemed highly correlated. They loaded together in the factor analysis and seemed to be the best measures of frontal lobe functioning. And so here's their battery of tests. I won't go into all these details, but number of categories achieved in the Wisconsin quad sorting test, the number of words generated in the oral wordization test, where you produce as many words as you can beginning with F and then A and then S, the mental arithmetic section of the WAIS Adult Intelligence Scale, the mental control section from the revised WAIS Memory Scale, and then the backward digit span from the WAIS. And so what we did for our older adults was to get weighted Z-scores that represent each subject's relative performance relative to the other older adults. We had 36. So eventually we classified our older adults simply by a median split in the high and low scores on this test. We only had 36. We couldn't do a more appropriate regression analysis. We first did a DRM experiment. This was led by Karen Butler. And we had 18, this was done at University of New Mexico before Mark McDaniel came to Washington University. We had 18 younger adults and 36 older adults who took this battery of neuropsychological tests. And in 2 experimental sessions, we tested for recall and recognition of 36 of the DRM lists. We at that point had 55 lists. We didn't have that many subjects, but we had many data points because we had 36 lists of words. Now, I'm going to show you what the subjects look like. This is the only study I'll do that for. But here are younger and older adults. The younger adults were 19, education, 13.7 years of age, 26 on a vocabulary test, and 36. And the older adults, mean age was 76 in our study, education level 16 and a half, vocabulary, you can tell, quite intact, much higher than for the college students in this particular test. And now what I want to do is show you when we divide the older adults into 2 groups. These are ones we're calling high frontal functioning older adults on the right and low frontal functioning on the left. We see there's a slight age difference. Education is the same. Vocabulary is just slightly different, not reliably. And on the other tests of cognitive functioning, they're roughly the same. So they're not huge differences here. And our low functioning adults, there's nothing wrong with them. They drove themselves in to be tested. They all live at home, that kind of thing. So these seem very high functioning adults. When they come into my lab, at least I would ask the research assistants who didn't know whether it was a high or low functioning, they couldn't tell. They said by dress or by conversation or anything, they couldn't tell. We kept them blind with respect to condition until after they were tested. But this was done in New Mexico. At any rate, that's the subject characteristics. Here's recall. I'll show you recall from this study. Here's recall from list recall. This is recalling immediately after the list. Younger adults did better than older adults. Excuse me. On the list items. But for the critical items, the words that were not presented, the older adults recall more than the younger adults. Not surprisingly, it just replicates what we showed before. If we break this down into high and low functioning older adults, what we see is that the high functioning older adults on accurate recall about as well as the young adults. 57% of the list items compared to 61%, 32% false recall compared to 31% for the young adults. So the aging effect that we see in older adults is really carried by those who score low on the frontal functioning test. They show 46% accurate recall and 52% false recall. So high functioning older adults are basically pretty much like young adults on these tests. So conclusion at this point is we replicate the finding that older adults are more prone to false recall and false recognition, by the way, than young adults. And the new finding is the effect is carried by older adults who score low on this battery of cognitive tests. Older adults who score well on the test are comparable to younger adults. And so what occurred to me as I was listening to Rogalski's talk at ICOM, well, maybe Mark and I found super-duper agers. Our older adults don't score, I'm sure they do score as well as 61-year-olds, but they also score as well as 19-year-olds. If you score as well as a college student, let's call that, since the word super aging has already been taken, let's call that super-duper aging. Let's turn to another paradigm, one that's thought by many people to be more ecologically valid, and that's the misinformation effect paradigm pioneered by Elizabeth Loftus and used by hundreds of people since then. And the paradigm that probably many of you know is a three-stage paradigm. You first see a crime scene on a video or an accident. Let's say there's a car accident. Imagine a car pulls up to a traffic sign. Let's imagine the traffic sign says stop, and the car pulls out in the intersection despite the traffic sign, and another car hits it. And later in the experiment, subjects receive some details about the scene. It could be posed in the form of a question, and the information that's embedded in the question could be correct information, and it could be false information, or it could be neutral information. So it might be, did the person stop at the intersection? That would be neutral. Did the person stop at the stop sign? That would be correct. Or did the person stop at the yield sign? That would be inserting an incorrect detail. And then finally, there will be a test on the details in the scene, and the interest is in whether the false information given erodes the person's memory for the type of sign that was originally there. So we can ask, do older adults show greater misinformation effects than do younger adults? And we could, one thought would be, yeah, of course they will. They'll show greater source confusions. They'll have both a stop sign and a yield sign buzzing around in their brains. But you could also say, well, no, maybe older adults will have worse memory for the misinformation, and maybe they won't show the effect or won't show it very powerfully compared to younger adults. The one prior study that we could find that was directly relevant at the time we did this was one by Cohen and Faulkner, and they found greater misinformation effect in older adults than younger adults, but then others reported results that differed. But these studies used various different measures, and that could have been one of the issues in these studies. So we tried again. We, as in this case, Lisa Geraci, a postdoctoral fellow with me, now at University of Massachusetts at Lowell, and we conducted another experiment using the misinformation paradigm and using the Galinsky battery of frontal tests. So there's three phases again. They saw two slide sequences in our experiment. Let me stick with the theft in an office for this example. And in this theft in an office, a repairman came in to fix a desk. And while he was fixing the desk, he stole a purse from it. And while he was fixing the desk, he used a screwdriver in one version of the scene. And so subjects later read a narrative that was supposedly written by another subject. And there were three conditions that varied within subjects for different items. And for some items, they got misinformation. They were told something like, did the man use pliers, or as the man used pliers to fix the desk, and then they were asked something. Other people, it was replaced with tool, did the man use a tool? And another, it was consistent, screwdriver. And so what you would expect, and what's repeatedly found in this paradigm, if you use pliers, you get the misinformation effect. People tend to recall that misinformation above baseline, the neutral baseline. If you get screwdriver, they tend to, that tends to help memory. You've gotten the information twice. And so you get the misinformation effect. And finally, how do you measure the misinformation effect? Well, there were two ways in this study. One, they took a yes-no recognition test on sentences like this. Sam took a pair of pliers out of his toolbox to fix the desk. And then they would say yes or no, did this happen in the original slides? And they were told to only focus on the original slides, be sure. And then after they answered that, they were told, okay, now here's another test. This is a source test. And you're supposed to say now, when you got this sentence, was this information in the slide, only in the slides? Was it only in the narrative? Was it both in the slides and the narrative? Or was it simply not mentioned at all? And so we've got two different measures of performance. One just was it pliers, and the other was where was pliers mentioned, if it was mentioned at all. Was it in the slides, or I'm sorry, if it was in the experiment at all? Was it in the slides? Was it in the narrative? Both or neither? And so let me show you the results. Relative to a neutral baseline, somewhat to our surprise, there's no big difference, no difference at all, in fact, between high and low subjects. If anything, the low frontal subjects did a little better, showed less misinformation relative to the neutral baseline than did the high frontal functioning subjects. But when we use the consistent baseline, that is, comparing misinformation to correct information when they had the correct information presented twice, now we do see that the low frontal functioning subjects show a much greater misinformation effect than the high functioning subjects. So that's with the just yes-no test, yes-no recognition. When we look at the source monitoring test, we see now that the low functioning older adults showed greater misinformation effects in both cases, both against the consistent baseline and the neutral baseline. So what we see here is that, yes, older adults show a greater misinformation effect. Those that score high on the tests that measure frontal functioning show a less pronounced effect. And the high frontal functioning is about like that of younger adults. In this case, like Washington University undergrads, whose older adults were 76, the undergrads were 19 to 20. Once again, we can see what we call super-duper aging. We find older adults who are just like, cognitively like younger adults. Final experiment shows the same thing. False recall, and this time we use categorized word lists. Again, back to word lists, but this a different kind that has different properties from the DRM list we used before. And again, the same idea. Now we have healthy older adults, 15 high frontal, 15 low frontal, 15 college students. And I'll show you what these lists look like. And the test we gave them, as I'll talk about, was what's called cue recall, where we cue them with the category names. And here are categorized lists. They're lists like birds. So what we did here in free association tests for US college students, here in order of the birds that college students come up with. And what you can see is that the top 5 are robin, sparrow, cardinal, blue jay, and eagle. And what we did was leave these out of the list we presented. So we presented the list of birds as below the line, crow down to dove. So we presented that as the items to be remembered, and false recall would be including the 5 most frequent birds that we had omitted from the list. So we had 6 lists presented visually, and in this case we had 2 tests. We just exactly the same test given back to back. So this was cue recall. They got the category name. Recall all the birds you can. Please be as accurate as you can. Please make sure you're not making any mistakes. And we also got them to rate the confidence of their responses, although I'm not going to talk about this. And we gave them 2 minutes to recall each category, the words in each category. So here's recall, correct recall. This is again cued recall. So older and younger adults didn't show that big a difference, except on the clinical items, they did show a difference. No difference in correct recall, but high false recall relative to younger adults. And the second test, oops, I'm sorry. Here's frontal status over here. And now we look and we see again, the high frontal adults are just like the young adults. The low frontal adults show much higher false recall than do the high-functioning older adults and than do the college students. So what we see here then is, again, the same pattern we've seen previously. If we look at the second test, another cue recall test, we see exactly the same thing, that the high frontal older adults look just like the younger adults. Low frontal older adults, false recall is quite high. Half the items that we omitted were placed in. So once again, though, high frontal functioning older adults are just like young adults. So I want to draw to the end here, sparing you a fourth paradigm that shows the same thing. And in conclusion of my talk, we see that older adults are more prone to memory illusions or false memories in three paradigms. Mark Twain is right. They show, generally speaking, less good correct recall in some paradigms, and they always show greater false recall or false recognition. Our theoretical account is that older adults have difficulties in source monitoring due to declining frontal functioning, but that not all older adults show this. And the older adults that are more likely to show it are the ones who score poorly on those tests that are purported to measure frontal lobe functioning. And the evidence is consistent across all of our paradigms on this point. And so coming back, did we discover super-duper aging in all these studies? If super aging is the finding that some 83-year-olds score like 61-year-olds, well, what we found in several different paradigms is that we've got 75-year-olds that score like 19-year-olds in a whole series of measures, both on accurate recall and false recall. We had 5 measures of cognitive performance to classify our older and younger adults, not just one. I'm sorry, for classifying older adults. And we never measured younger adults on the battery of tests. And we had several different paradigms that showed the effect. And so in some ways, our evidence for super-duper aging, as we're calling it, is more robust than it was for super aging, where there was only one test. Now, coming back to our illustrative framing research, Rogalski and colleagues found older adults who performed like 61 years old, and they called them super agers, and everyone got excited. But when Mark McDaniel and I found older adults perform like young adults, we called them higher frontal older adults. We published our papers, and everyone yawned. So it matters how you describe your phenomena. So are we, Mark McDaniel and I, now allowed to go back and claim we discovered super-duper aging before our colleagues at Northwestern discovered super aging? Well, I just did that in the talk that I just presented. And I've only given this as a talk. I've never written this work up. I mean, all the original stuff is written, but we never made this point, obviously. So let me end there. Sorry if I ran just a bit long, and I'll open it up to questions now. Thank you.
Thank you very much, Professor Roediger, for this exciting talk and for the lovely work over the years that you've done. We have a few questions that have come. Perhaps you've seen some on the Q&A session. I think we can start with maybe Paris Travacoli's question, and that relates to how does one remember and whether that has an influence. For example, she talks about associations. Some people use a lot of associations in remembering. Does that affect how we will have problems in relation to memory with aging and also false memories?
Well, let's see. If I knew how we remember, I would be a lucky person. But yes, we have been studying that for a very long time. And certainly many theories of memory are associative in nature, John Anderson in particular, but others. And so the lists that we created, say in the Drm paradigm, are highly, the ones that work best are highly associated lists, or lists where the items in the list are associated to the word that's omitted from the list. So the idea is things like bed, rest, and awake will cue the word sleep unconsciously or maybe even consciously, and therefore it gets mixed in with the list words. And even though it's not preserved, it's recalled like a list word. And one idea, we know that older adults and even patients in early to mid Alzheimer's disease, their associative networks are intact. They show relatively normal levels of priming in certain tasks. They obviously show reasonably good performance on the DRM task. And so, yes, having a good associative network certainly improves memory, if that's the question.
Okay, well, thank you. So the other question, I guess, which has been asked by Faruqi, and of course endorsed by a number of other people, they're quite interested in is how does the frontal lobe compensate for the deficits, if there are? What are the mechanisms?
Some brain imaging studies show that for young adults, there's more activity in one frontal lobe, say right frontal lobe, during retrieval, and that as people age, there's activity in both. So it's as though you're trying to recruit extra resources to bring to bear. And Roberta Cabeza, for example, has at Duke University has brain imaging data relevant to that. So the brain is trying to compensate for some difficulties by recruiting extra regions to help do the work. That's a hot area of research.
Okay. Okay, so let me address this question, I guess. Have there been any studies of people looking into age groups that are 90s and above, really? So you're talking about people in their 80s. What happens as people grow older into 90s and maybe crossing 100?
Yeah, some work, Beth Fairfield at Chieti University in Italy, and around she came and visited Washington University, and I was stunned to hear her give a talk where she had, age groups of 70s, 80s, and 90s, and she even had some people over 100, because people in that part of Italy seem to be particularly long-lived. And she showed, she didn't have our battery of tests and all, but she showed people in their 90s who were doing pretty well on memory tests. And so I was quite impressed by that. But I've never done any of those studies myself. Our oldest subject in the studies I just told you about was 91.
Okay. Yeah. Thank you. So I think I suppose one clarification Maureen has asked for is the sort of separation of high versus low functioning. I understand that was based on the frontal battery that you had.
Right. Yes.
Yeah. And I remember that you had one was minus 0.3 standard deviation or something. The other one was
right.
plus 8.8 standard deviation.
Yeah. And we haven't, to answer a question I thought somebody was going to ask, do we have any measures of brain functioning, either structural or functional imaging? And the answer is no, we don't. But that would certainly be of interest to us to collaborate with somebody on that and see what is it about these 75-year-olds or that group that makes them seem like younger adults. If we look at the neural signatures, do we see similarity, or are they simply compensating in some very good way for aging brains, or have their brains really not measurably aged? That's a very interesting question, but I don't know the answer to it.
Sure, there are lots of data around for that,
Right.
huge amounts of data. So it's just a question of going back to the data and looking at this specific question, I think. Yeah. So I think it brings me to this other question, which has been asked by a few people. What happens to these people who are super agers? Do they have an advantage in terms of longevity, in terms of general health, and so on?
I'm not sure if the Northwestern group has looked at that, There is a classic adage in psychology that all good things correlate positively about 0.20. So I would bet they do, I bet they're less likely to convert to Alzheimer's disease. In fact, some other people at Washington University track that kind of thing and look at what determines whether people will convert to Alzheimer's disease later in life. I'm not involved in that research, but Dave Bellotta and some of my colleagues are. I do imagine they're probably longer lived. I imagine, as I say, all good things correlate. But I should say there's really nothing that we can tell that was wrong with what we're calling the low frontal older adults. They, like all of them, they drive in, they come to our lab, they find their way. They often stand around and chat later. And Michelle Mead, actually, who Koch Numbers there worked with, she tested a lot of older adults, and she's such a nice person. They would often come back and talk to her when they're in the building for some other experiment. So we had problems keeping them out of the lab because they all wanted to talk to Michelle. But it's a very competent group in general. So
yeah, okay.
Not like there's anything wrong with what we're calling the low frontal older adults. Anything detectable.
So one question I had is the question: if someone was to start research into super aging now, so if you have a young PhD student, and in fact we have a PhD student who's interested in doing this work, what definition of super aging or super duper aging, whichever you want to study, would you use? I mean, there are so many different possibilities in terms of looking at cognition, not just cognition, but also health, social function, etc. So what advice would you give a young person?
Well, I would certainly use a more stringent one than being like a 61-year-old, because they're old too. So since you can find people who function, and we weren't even trying that hard, we didn't highly select these, but we had a very good group of older adults we selected from. They were often in many types of research, but they were a general community sample. And I would try to get the ones who can do about as well as college students, and because you can do that, and I think it's more impressive than getting someone who's kind of like a 61-year-old.
Yeah. Okay. Thank you.
I would start there at least and see if you can't find them. I'm sure you can.
Oh, yeah, sure. Thank you. Yeah. Now, there's a question from Jill Floyd, and I think she's possibly referring to the implications of low frontal functioning. She says a comment on the observations about difficulties in source monitoring in low functioning frontal lobe older individuals could explain some of the interpersonal conflicts that arise in retiree service organizations and retirement villages for retirees. So do you think can you make this link?
Well, yes. I think people who, obviously as we age, many people get in conversations about who said what when and who meant what, and did I say this yesterday? And older adults are much more likely for that to happen than younger adults. One of my former colleague, Larry Jacoby, who's retired now, he had a paradigm, one of the hallmarks, I think, of having dementia that I observed in my own grandmother is retelling the same story or asking the same question while you're involved in the same conversation. And so a question pops to mind and you don't monitor whether you've just asked this question. Maybe you even know the answer, but you're just covering up, trying to make the conversation work. And that kind of repetition, that kind of forgetting is a real hallmark of mental decline, I think, and a number of different paradigms and cognitive psychology that I've heard talks about over the years tend to show that.
Okay, thank you. So one of the issues raised, I think Paris raises this issue, is the confounds here in investigating or studying older people. And many of them have sensory impairments, say hearing and eyesight impairments. So how do you account for those? Or are your subjects selected to not have some of these impairments?
We do give a checklist on, is your vision corrected to normal? We don't worry about hearing too much because the experiment is all visual. They're reading everything or watching videos. And so we worried more about vision. And yes, a lot of the older adults, in fact, a lot of the younger adults too, are wearing corrective lenses, either contact lenses or glasses. So, but we think they're corrected to about normal vision just by self-report. We didn't do any vision tests.
Yeah, okay.
But it would be unusual if it were the people who scored differently on the frontal test also had differences in vision. I mean, it's possible, but probably unlikely.
Okay. So, an interesting point raised by Imad Omar is we comparing an older group with a younger group, but is it that the younger group is not any smarter or getting less smart with time, or is it a cohort effect in the negative direction, he says, rather than a positive direction?
That's unlikely. Our Washington University undergraduates are highly selected, and there's also the Flynn effect where the IQ tests have to be revised upwards all the time. So in all likelihood, the cognitive demands and placed on younger adults these days are higher than the ones that were placed on me and other older adults when we were that age, less to keep up with. So I doubt if the younger adults are not as smart as they used to be. I will say though that we didn't give the batteries of tests to the younger adults because we figured, oh, well, they're all high frontal. But Jason Chan and Kathleen, Jason Chan was a graduate student at Washington University, and Kathleen McDermott, his mentor, they did do that with Washington University undergraduates, and they did find that the ones who scored lower on the frontal tests also did worse on other cognitive tests. So it was possible to do that with younger adults, even college students.
Yeah. Okay. Thank you. I mean, there are a few questions you might have seen which are more relating to the experimental design, perhaps, that use. There's a question about gaps, what is gap in, or the rest period between a learning test and the recall test. There's also a question about whether this battery has been applied to FTD participants to see how they perform.
No, not to my knowledge. And the intervals between, so for example, in the wordless paradigms, the tests were immediate and the instructions are, please don't make errors when you're recalling or recognizing. Please be conservative. Don't put down anything unless you're sure it's absolutely correct. You're sure you just saw it in the list. And so, I said everything was visual. Now it occurs to me one of the experiments was auditory. But anyway, the other two were visual. But so we told them, depending on the experiment, be absolutely sure you heard it or you saw it in the experiment. Don't guess. And so even when you give very conservative instructions, you get those high rates of false recall and false recognition.
Yeah. Okay. Thank you. So finally, I think we might address two questions. One is, what do you think are the determinants of super aging? Can you say what makes these people super agers, and then can we do something to become super agers ourselves? Is there any intervention you can recommend?
Well, probably many people in your audience know this literature better than I do. Brain training games don't seem to work that well. They're touted at least in North America. There are all kinds of brain training games. They seem to help on the task you're trained on, but they don't seem to generalize. Some studies find that physical exercise, particularly aerobic exercise, seems to help. The brain is an organ that needs oxygen, just like the heart and other. And if you're pumping more oxygen to your brain when you exercise, that might help you. Again, I'm speculating here, but there is some evidence that shows that exercise helps. probably staying cognitively engaged, reading, doing involved in complex mental effort. That probably all helps. The evidence is not totally, is mostly correlational, and you don't know whether it's that older adults who are cognitively functioning well can do those tasks, or whether those tasks make them function well cognitively. It's hard to get out of that correlational trap.
Yeah, I think that's a great message to end your talk with. And thank you so much once again for staying for the session, for the time you've given to this talk. And I think it's been very engaging, and you can see from the response from the audience that people have been very interested. And certainly we look forward to future interaction and collaboration. So thank you once again.
Okay, thank you.
Thank you. And I'd like to thank all the attendees for joining us at this expert talk, and we encourage you to complete the survey that you will receive shortly. And also to register for future visiting lecture series, please make sure you subscribe to the CHIBA's newsletter or check our website. Thank you and goodbye.